We are on page 25 of the student note packet. I'm going to walk through number 7 with you guys, which is one of your homework problems, and then you will finish the rest of that handout for homework. So that is 9-4 polar intersections day 2. We're going to do number 7 because it's one of the most complicated, and then you guys will get started on the rest. So one thing to note here really quickly, that y min, y max, y units, x min, x max, that would be if you're using your graphing calculator to check what values would be typing in for all of those in order to set the window. I would say just cross that out. Use Desmos. It's way faster. You guys are at home. You've got that access to Desmos. And it's just easier to kind of check your graphs that way than with a graphing calculator. But if you have questions on that, just shoot me an email. Let me know. You guys can just skip that part though. Okay, so for number 7, what we're going to do is we're going to actually do the algebra first. If you guys take a look at the two equations we've got 7 cosine 3 theta and 2 cosine squared 3 theta minus 4. Now, the one on the left, that's a polar flower. We know we have 3 petals because the value of B is 3, it's odd, and then an amplitude of 7. So we're going to extend out to 7 as our maximum petal tips. But on the second equation, we actually haven't talked about graphing squares. So what we're going to do with that is we're going to just make a table of values, and then we're just going to plot those points. If we do the algebra first, that gives us an additional set of points to actually put on our graph so we can see really accurate graphs that way. So that's what we're going to do, is the algebra first, so that we can take those points in our solution. We can put that on the graph as well. So we're going to start by setting each of these equal to each other. 7 cosine 3 theta is equal to 2 cosine squared 3 theta minus 4. Hopefully we can see where this is going. We've got cosine and cosine squared, which means I'm going to get everything on one side, and then we're going to be able to factor this. Now, this is factorable because the angles are the same. Both of the angles for cosine are 3 theta. If it wasn't, if they were different, we would not be able to do this with the same approach. All right, so when we factor this, we're going to have a 2 cosine 3 theta. You can use substitution if you'd like. I'm just going to factor it with the cosine 3 theta right inside as is. And we need the middle term to add to -7 here. So I believe that's going to be 2 cosine 3 theta plus 1, and cosine 3 theta minus 4 is equal to 0. Right, the 1 and -4 multiplied to -4, and then we'll get -8 cosine 3 thetas plus 1, which gets us to the -7. All right, now we can set each of these equal to 0, and we can solve. So 2 cosine 3 theta plus 1 is equal to 0, or cosine 3 theta minus 4 is equal to 0. So the cosine of 3 theta is equal to -1/2, or the cosine of 3 theta is equal to 4. Now, something really nice. This second factor, the cosine of 3 theta will never equal 4. Remember that the maximum and the minimum here is what the amplitude is. It's just 1. So we would take the inverse cosine, right, of 4, and you can't do that. You get an error in your calculator, so we don't even worry about that one. We can just cross that out. We're only working with one principal value here. So the cosine of 3 theta is equal to -1/2. The principal value is going to come from the inverse cosine of -1/2. We're going to be careful here. We're now in radians. So our principal value is the angle whose cosine gives us a -1/2 value, and that's going to be between 0 and pi here. So what angle has a cosine of -1/2? Well, that's 2 pi over 3. Now remember, it's been a while since we've done this, but because we had 3 theta on the inside, the general solution equations both get set equal to 3 theta. So they get set equal to everything on the inside of the cosine. Our first general solution equation is the principal value plus 2 pi n. Our second general solution equation is the negative principal value plus 2 pi n. That's for cosine. And in both cases, we need to divide by 3 in order to solve for theta. Right, so our first general solution equation here is going to be 2 pi over 6, which is going to be pi over 3. Not 6, it's 9. 2 pi over 9 plus 2/3 pi n. And then the second general solution equation, do the same thing, divide by 3. That is going to be -2 pi over 9 plus 2/3 pi n. Okay, so two general solution equations. Now we move on to the particular solutions. So I'm going to make a table. Doesn't matter to me how you guys choose to do this. And I'm just going to plug in some values here. See what we get. Now we're looking at the particular solutions that are between 0 and 2 pi. Okay, so I'm going to start with our first general solution equation. When n is 0, we get 2 pi over 9. Now remember, 0 to 2 pi, what we're looking for, I'm just going to turn 2 pi into something over 9 so that I don't have to do a lot of thinking when I start getting solutions. So 2 pi is the same thing as saying 18 pi over 9. So that's like our upper bound if you want to write it in the same denominator. All right, and then one other thing here, that 2/3 pi n, that would be the same thing as adding 6 over 9 pi n. And so that just kind of helps us do the math a little bit easier with fractions. All right, so when n is 1, we get 2 pi over 9 plus 6 pi over 9. That's a total of 8 pi's over 9. Still less than 18 pi's over 9, so we move on. When n is 2, we get 12 pi over 9 plus 2 pi over 9. That's 14 pi over 9. Also still less than 18 pi over 9. And then when n is 3, we get 18 pi over 9 plus 2 pi over 9, so that's out of the bounds of 0 to 2 pi. And then we move on to theta 2. So when n is 0, we get negative 2 pi over 9, so that's kind of out, right? That's a negative value. It's not kind of out, it is out. When n is 1, I get 2/3 pi, or 6 over 9 pi, plus negative 2 pi over 9, so that's going to be 4 pi's over 9. And then when n is 2, here we get 12 over 9 pi's minus 2 pi's over 9. So that's 10 pi's over 9. Still less than 18 pi over 9. When n is 3, we get 18 pi's over 9 minus 2 pi's over 9. So that's going to be 16 pi's over 9. And then I'll just do like one more check kind of mentally. If I were to go to 4 here, we would get 24 pi's over 9 minus 2 pi's over 9. So that's greater than 2 pi. So we have 4 solutions. We just need to list them in order because I think it's always easier to translate them onto the graph. Plus, that's how I'm going to ask you guys to do it on your test. And we're going to write the particular solution. So I'm going to set up 6 ordered pairs. 1, 2, 3, 4, 5, 6. All right. And let's start filling in the angles. Now remember, it's r comma theta. So our first theta here, our smallest value, is 2 pi over 9. And then it looks like it's 4 pi over 9. And then 8 pi over 9. 10 pi over 9. 14 pi over 9. And then 16 pi over 9. And then we've got to find the value of r. So pick one of the 2 equations. I will probably pick the easier of the 2. So I'm going to pick 7 cosine 3 theta, and we're just going to evaluate. So when we plug in 2 pi over 9 into theta, we get 3 times 2 pi over 9, which is going to give us 2 pi over 3. So the cosine of 2 pi over 3 is negative 1/2. So r is going to be negative 7/2 for this point. And then I will do that for every single other value I've got here. So I'm just going to make this really quick. When you actually evaluate, you're going to get negative 7/2 for all of these points here. Okay, so that gives us a set of 6 points to put on our graph. And then in addition to that, we'll make our t-table for this second curve and have more points to kind of plot to make the graph look really accurate. Okay, so what I'm going to do is I'm going to kind of get you started on the graphs, and then you'll just finish plotting the points, and we'll come back and do like the final solutions here. All right, so I'm going to color code this. That first graph, you guys, that's just a polar flower. B is 3. It's odd, so the number of petals is equal to 3. What else do we know? Well, I know that we start at 0 degrees because cosine always starts at 0. If this was sine, you'd have to find that first subinterval length. And then the spacing is kind of the last thing we care about with polar flowers, and that's always 360 divided by the number of petals. So we'll start our first petal tip at 0, and then we'll go every 120 degrees, a new petal tip. And then the one other thing we don't want to forget here is that we're actually going to extend all the way out to 7 because the amplitude is 7 on this one. The other curve is the one that's slightly more complicated. So 2 cosine squared 3 theta minus 4. I'm just going to make a table of values. So I'm going to keep track of theta, and then I'm going to keep track of 3 theta because I think sometimes it's just less to do in the same calculations. So it's really up to you what you want to do. The one thing we have to remember though is that when we go back and we actually graph this, you will be graphing theta and r, not 3 theta and r. And I'm going to start by picking all of those angles that we've kind of just been working with, 0, 90, 180, 270. And then because this graph is so complex, I'm going to pick a few more. Cosine is really nice with that 60-degree angle family. So 240, 300. And then one more angle family I am going to include is the 30-degree angle family. And the reason why is because we're squaring cosine. So that root 3 over 2 value we'll get at the 30-degree angle family. That gets squared. So we end up getting rid of the square roots, and we'll kind of see what happens on that as well. So that's going to be 30, 150, 210, and 330. So let's calculate 3 theta for each of these. I'm going to mark the angle that is coterminal on the unit circle, and then we'll evaluate for r and have some points to plot. Okay, so 0 times 3, that's just 0. 90 times 3 is 270. 180 times 3 is actually coterminal with itself. And then 270 times 3 is coterminal with 90 degrees. 60 times 3, that's 180 degrees. 120 times 3, that's coterminal with 0. 240 times 3, also coterminal with 0. 300 degrees times 3 is coterminal with 180. 30 times 3 is 90. And then we're going to keep going. So go ahead and pause this video. Maybe try and get the values of r as well. And then start plotting those points. And we'll kind of put it all together in a minute. One thing I am going to note here before I actually plot all these points is that the maximum on this graph is 6, but our maximum is actually 7 for that first graph. So all I'm going to do is just pull another ring out that represents 7 so that I can scale this by 1 and kind of get a really nice looking graph that fills up all the space. So you guys can do that if you just draw another ring around, and then we'll call that 7, and I can scale this by 1. I'm going to start plotting all of these points, including the solutions, and then kind of connect the dots and identify the places of intersection. All right, so once I've plotted all the points, in purple we've got the solutions, and I did that before I actually drew in the flower petals for the first graph, just to give us kind of a better idea of what the width is going to look like on those guys. And then that last curve, that cosine squared curve, there is no point at the origin, so we're not going to 0 anywhere. It's just that flower that kind of sits in the middle, that's centered at the origin. So that is number 7. You guys are going to work through the rest of the problems for homework. Email me if you've got questions or drop into office hours.